Well, hello, wonderful physics students. Welcome back, and we get to start electrostatics. Woohoo! So, our first thing that we are going to be learning about is charge. So, let's get to it. Okay, so the basic model of the atom that you guys learned from chemistry last year is that the nucleus of the atom has positive charges in the center, protons, and electrons are orbiting the nucleus, like so. So this is the basic Bohr model for the atom. Okay, so modern view of charge. It comes in two flavors, positive and negative. It's normally balanced, and the amount of positive charge on that object is fixed. It's very easy to pull off an electron off the outside of an atom, but it's very, very difficult to pull a positive charge out from inside the nucleus. In fact, to do that, you would have to split the nucleus of the atom, creating two different elements. And so the way that we change the charge of an object is that we move around the electrons. We don't mess with the positive charges. The amount of, the imbalance of charge, the imbalance of positive and negative, causes an object to be charged. Okay, so let's take an object. Let's say we'll take my Starbucks cup right here, and it has an equal amount of protons and neutrons in there. So in this graphic right here, protons, so the amount of protons, think of it like a bar graph. The amount of protons and the amount of not neutrons, electrons are even. So positive and negative charges are even. So this, we say that this is not charged. Now if I add electrons to this mug by charging something and touching it, I could say that this is charged. So if I add electrons, I have more electrons, more negative charge than positive charge. So this excess negative charge is what is called the charge of an object. So it's just this extra bit of charge. It's not the whole, all the negative that we have. It's not all of this. It's just the extra little bit. Okay, so let's go back to neutral. How would I make something positively charged? Right, so you can't put in more protons. We can't change the number of protons, but we can change the number of electrons. So if we take away electrons, you have now this extra bit of positive charge. So this now is the positive charge of the object. Okay, so let's talk about order of magnitude and how many electrons are we talking about. So typically when we charge an object, we're adding or removing somewhere on the order of 1 × 10⁸, 100 million electrons. That's a lot. Okay, so when we measure charge, charge is measured in coulombs. That's the units of charge, coulombs. It takes 6.25 × 10⁸ bare protons to make 1 coulomb. So a coulomb is a large charge. So, knowing this, I want you to calculate the charge of a proton. So pause the video and see if you got it right. Welcome back. Okay, so if it takes 6.25 × 10⁸ bare protons to make a coulomb, so then we know the charge of a proton is 1 divided by 6.25 times 10⁸. This is protons per coulomb. And you divide it out and you get 1.6 × 10⁻⁻19 coulombs. So this is the elementary charge. Charge is quantized, which means that every electron and every proton has this charge. So all charges is a multiple, all the charges of an object, of anything on Earth, is a multiple of this elementary charge. So we have 1.6 times 10 to the negative 19th coulombs. And if an object is charged, it's always just a multiple of this because we have so many electrons added or taken away from an object. So we say that the charge of an electron is equal to the charge of a proton, but negative. So the charge of an electron is negative E, and the charge of a proton we just denote as E, positive E. Okay. So let's work out one problem here, and then let's just get this one example. A penny contains 2 times 10 to the 23 protons and an equal number of electrons. If the penny is charged to 1 coulomb, what fraction of the electrons have been added or removed? Okay, so remember we talked about 1 coulomb being a big, huge charge. If something's charged to 1 coulomb, it's a large charge. So we're going to make this a positively charged penny, so we're going to have to remove the electrons. The fraction removed is equal to the number removed over the total. So the total is 2 times 10 to the 23rd, and we said that we're removing 1 coulomb, so that, remember, was given as 6.25 times 10 to the 18th number of electrons. So that's only this tiny, 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 tiny fraction. It is 0.003% of the electrons in the penny. Okay, so the next video we will talk about inducing charge and conductivity.